So when we're graphing these quadratics, yes, it is so much easier to be able to just play with the calculator and open it up. But I think you'd probably agree that finding the vertex might be actually the trickiest thing we do, even though it's not bad once we get used to trying to see where it's at. So here's how this is going to work. So as we were talking yesterday, we'd punch this in. So let's go ahead. I'm just going to kind of repop this one up for a sec. Just as a quick reminder. So we'd go looking around until we saw the same numbers keep getting repeated. And then we'd go to the odd ball in the middle and say, okay, that's our vertex. There's a way to do it algebraically, though, that's rolling down the same idea. And that's the one thing we're going to add to your notes today if you want another option to know exactly where the vertex is, and then I can pull it up on my chart. It's kind of nice. So we're going to add this up at the top because there's a whole lot going on with the rest of this stuff right now. And we're just going to call this vertex option. We'll go deeper into this a little bit later here. Now, you might look at me when I first write this and go, okay, Hardy, now wait a minute. What is this negative b over 2a thing that you're talking about here, and how that work? So when you're looking at your equation like we are here, and I'm going to kind of combo do these at the same time. So when I'm looking at these, this is, in math terms, what we call, this is the generic form of a quadratic equation. And so all that a, b, and c number is the number in front of x squared, the number in front of x, and the number that's hanging out on the end by itself. So if you wanted to find your vertex, or at least the x value of it this way, here's how this would work. Well, I think it is too, but sometimes it's good to have an alternate option just in case. So here, my a would be 1. My b would be negative 6. And my c would be 10. So to find the x value of my vertex, if I didn't want to kind of just go searching around, we'd do this negative b over 2a thing. So we do the opposite of negative 6, which is positive 6, over 2 times 1. And for me, I kind of agree with Landon. Myself, I think it's personally easier to grab my calculator, go to y equals, I'm going to try to get away from, there we go, and just type in so just a couple of quick reminders from yesterday on the button presses when we're doing this. Actually, I'll run back one more time here. This xt theta n button right next to alpha, that's my x button. And then where it says x squared down here is how I get my squared up. Everything else should be pretty straightforward. And so once I get here, normally what we did was we hit second and graph to get my chart, and I had to go searching around until I started seeing, ooh, there's 10 and 10, 5 and 5, 2 and 2. And I'd finally find that one number in the middle that's the oddball. but all this symmetry around the outside. But check this out, it's at 3, 1. So if I wouldn't have been able to find it, let's say I was having trouble, if I do this, this will tell me what the x value of the vertex is, and it'll help me locate it a little bit more. So either one is going to work, but that's just kind of a nice option. So our vertex goes in the middle, and then we're just going to take the chart and we're going to copy the x and y values 2 above and 2 below our vertex. Because again, we'll see the symmetry that's going on with the y values. That's going to be the same every time on these. And so once we've got that vertex taken care of, and again, totally up to you if you're wanting to deal with this stuff right away or just find it in the calculator. We'll play with both. And once I have that, now here's my x and my y axis. So 3 for x just means we're going to go right 1, 2, 3, and up 1. There's my first dot. Or I could go up here if I wanted to. So x is 1. We're going to go right 1 and up 1, 2, 3, 4, 5. We're going to go right 2 and up 2. I already got my vertex. Right 1, 2, 3, 4, up 2, and right 1, 2, 3, 4, 5, up 1, 2, 3. And you should get something that kind of lets us see a curve, even though it kind of looks more like a V, but it won't once we kind of get our practice here at graphing. We're wanting this to curve and then get out to both the edges, okay? So once I get my graph set, it looks like the only thing we got left here is we've got the min versus max game, which we chatted about some yesterday. If our vertex is at the bottom, down in the valley, we've got a minimum. Okay, if my vertex would have been on top of the mountain, we had a max. We also chatted about domain and range. Okay, so our domain here, this is the easy one on every single one of these. Every single time. No exception. Your domain is always infinite because they're always going forever to the left and to the right. The arrows tell us that. My range, I'm going to steal from my vertex. Because if I take the bottom of my y's and I follow it back to the y-axis, it's at 1. So this number and this number will always match. Lots of pattern stuff. And then it goes up forever. So I get my infinity. So as we play with these, that's going to just be the same stuff that we're doing over and over. But again, there were some mixes of things. So I'm going to kind of bounce around a little bit in the assignment because I want you to see some of the different stuff and also some of the different things that we're labeling with this. So we're going to go over, did I see a fraction back here? I did. We're going to go to number 8. So over on page 4, we're going to check out number 8. And reminder, whenever there's a fraction in these, anywhere in your problem, you're going to want to put parentheses to make sure that we don't get something funky here. So again, if you're kind of new with the graphing, just a couple of hints. Y equals, we'll get you to the y equals screen, that makes sense. Clear over here is your one-step one-stop shop to clear those out. And we're just going to start typing this in. Again, we don't have a fraction button. We're just going to use the division button here. So 1 divided by 2 in the parentheses. Again, there's our X button here with a bunch of other stuff on it. And squared. That is a minus 4x. We went heavy with this yesterday. This is minus, this is negative. So if it's in the middle of the problem, we're going to use this minus. 4x plus 10. Okay. Looks kind of weird, but we've got it in there right. So I'll look at the picture quick, just to make sure it still looks like a parabola. Yep, it's kind of wide. Okay. Still looks like our U shape. Second in graph will get us the chart we want, though. So I start looking, and I'm like, okay, let's see. Ooh, I actually see quite a few opposites already. So I see 10 and 10. I'm looking for matches. I see 6.5 and 6.5, 4 and 4, 2.5 and 2.5. But there's my one in the middle that's the oddball. That does not have a partner to match up with. So the one that doesn't have a partner to match up with, that's my vertex. That's the middle of my graph. And so once we get that in the middle, yes, we're going to get decimals sometimes. That's okay. So I'm going to go ahead. I'm going to take those next two pairs of numbers above my vertex, the x and the y. And then I'm going to take the two that are directly below that as well. And again, when I make my chart, these should pair off every time. If you get different values and they're not pairing off, you haven't found the vertex yet. And so once we're here, now again, we're just plotting coordinate points. So 2 up 4, right 3. Now this gets interesting. Up 2.5. So up 2 and then just between the next two numbers. Don't have to be perfect. Right 4, up 2. Right 5, 1, 2, 3, 4, 5, up 2.5. Right 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4. So we're going to get a really, really wide graph this time. And again, we're going to just steal all the rest of the information from the graph. My vertex is down in the valley. That's a minimum. Domain, I never have to think about. It doesn't matter what the graph looks like. I'm good. And then range again. We're opening up. When range opens up, the bottom of my graph starts at 2, and then it goes up forever. It's just getting used to what those pieces are and where I'm going to find the answers to them is basically what we're looking for here. So one more thing to show and one more thing to remind you of, because there's one piece of yesterday's that we haven't really talked about yet. So we're gonna head for that here next. So we got one more page to play with. Gotta flip this over, get some things back up here shortly. So I get here over to page 5, and this is where I think we got adding to do. I gotta look. Yes. So we're gonna jot a couple things down here at the top before we get started over on the Noisy Pepper. Here we want to do domain range. And the one we haven't talked about yet today, the axis of symmetry. So, as we've done on the others, we're going to play around with number 2 here. So, we're going to get this one typed in as well. So we're going to do y equals, and we're going to clear. This is, since it's in the front, this is negative. So we're going to do this one instead of this one. Otherwise, you'll get an error message. There's my x. There's my squared. Plus 10. Okay, so let's see what this looks like first. We'll kind of go from there. Ooh. Okay, opens down because of the negative. But yeah, that's really tall. So, okay, let's see what we got here. So I don't see a whole lot matching up so far. So I'm like, scroll up a little more. Ooh, wait a minute. Negative 15, negative 6, 1, 6, 9. There's my oddball. So my oddball is at 0, 10. That's my vertex. And now we're just going to start copying stuff. So negative 1, 9, negative 2, 6, and a couple below. 1, 9, 2, 6. Get my axes labeled here. So let's see. So 0, none left or right, up 10. 1, 2, 3, 6, 7, 8, 9, 10. Left 1, up 9. Left 2, up 6. And then right 1 and up 9. And right 2 and up 6. So we've still got the V shape, it's just heading downward this time. Excuse me, my U shape, I think I just said V, that wasn't, this is not an absolute value graph. And so once we've got those, we are going to still add in the domain, reminder to self. Even though it's opening down, it's still negative to positive infinity because it's still opening wider and wider forever. Range is a little different though. You're like, Hardy, well, it's not the 10. It is, but remember, this is bottom to top. When I look at the bottom, I see the arrows going forever. But they're going forever down to negative infinity. And the top of my graph is up here at 10. So I'm still using that y value. I'm just using it in a different spot. And then for the one part we hadn't talked about yet, the axis of symmetry. Wherever your vertex is, we're going to draw a line through there, and my axis of symmetry will always be x equals and the x value of my vertex. So I have good use for my vertex in multiple places, not just looking straight ahead. So that's kind of what we're up to here. Just again, playing with the calculator, getting used to the button presses, where do I find stuff, things like that. If you want to do the puzzle, you can. All you're doing with that is the specific values you have here, like you would find negative 2, for instance. We'd put an I in there. We find 9. That's a G. I think there was only one of those. 0 is E, E, E. And I could keep going that way, but it's just those 4. So pages 3 through 5, again, just getting some practice. We're still going to be getting practice with a different form of this tomorrow. But I will also get the notes up here momentarily if you need to get those down from yesterday as well.